Hi everyone. Now let us take one PYQ. Let the set of all values of P belongs to capital R, for which the roots of the equation x square minus of P plus 2 into x plus 2P plus 9 is equal to 0 are negative real numbers. Be the interval alpha comma beta, alpha open, beta closed. Then the value of beta minus 2 alpha is equal to dash. This problem was given on April 7th, 2025, shift 1. So in the first video, I told the conditions for both the roots of the quadratic equation greater than k. Now in this problem, you see both the roots of the quadratic equation less than k. If alpha comma beta are the roots of this quadratic equation, then both the roots of the quadratic equation are less than k. By implies, these three conditions must be satisfied. A into f of k greater than 0, minus b by 2a less than k, and d discriminant greater than or equal to 0. I will verify the conditions only for one parabola C. A greater than 0, d greater than 0. Parabola is upward parabola intersecting the x-axis in two real and distinct points. So when both the roots are less than k, I will verify those three conditions will be satisfied. See here, alpha comma beta are to the left of k. Therefore, I can say that alpha comma beta are less than k. So this condition is satisfied. Then I will verify these three conditions. See now. A greater than 0, f of k greater than 0, because it is above to x-axis. A greater than 0, f of k greater than 0, a into f of k will be greater than 0. Minus b by 2a is x coordinate of the vertex. Minus b by 2a is to the left of k. Therefore, I can say minus b by 2a less than k. Parabola is intersecting x-axis in two real and distinct points. Therefore, I can say discriminant must be greater than 0. Similarly, you can verify these properties for the remaining three parabolas also. See one more particular case. See now. If k becomes 0, alpha comma beta are less than 0. That means both the roots of the quadratic equation are negative. So the conditions for both the roots of the quadratic equation are negative can be obtained just by substituting k is equal to 0. That means a into f of 0 greater than 0, minus b by 2a less than 0, and discriminant greater than or equal to 0. So these are the conditions for both the roots of the quadratic equation to be negative. See solution to the problem. Both the roots of the quadratic equation are negative. So just you calculate the range of the parameter p. See the solution. So let us suppose that f of x is representing this quadratic expression, that is x square minus of p plus 2 into x plus 2p plus 9. Say that quadratic expression is represented with f of x. For both the roots to be negative, I told that we have to take k is equal to 0. So let us consider the first condition. For both the roots to be negative, first condition a into f of k must be greater than 0. There a representing coefficient of x square is 1. For a negative roots, I said that we have to substitute k is equal to 0. Therefore, f of 0 must be greater than 0. So what is f of 0c? Just you substitute x is equal to 0. 0 minus 0 plus 2p plus 9. 0 minus 0 plus 2p plus 9, that must be greater than 0. Otherwise, I can say this can be written as 2p plus 9 greater than 0. Therefore, p must be greater than minus 9 by 2. So, p lies in the interval minus 9 by 2 to plus infinity. Say that is first condition. So, for a into f of 0 to be greater than 0, p must lie in the interval minus 9 by 2 to plus infinity. Let us consider second condition. Second condition I told minus b by 2a, that should be less than k. So, minus b by 2a means minus of minus, that will become plus 2 by 2 into a representing coefficient of x square. For negative roots, we have to substitute k is equal to 0. So this can be written as p plus 2 must be less than 0. Therefore, I can say that p less than minus 2. That means p belongs to the interval minus infinity to minus 2. So second condition is satisfied if p lies in the interval minus infinity to minus 2. Take third condition. Third condition I told discriminant greater than or equal to 0. So there b square representing p plus 2 whole square, b square minus 4ac, 4 into a becomes 1, c becomes 2p plus 9, that must be greater than or equal to 0. So expanding the first bracket, p square plus 4p plus 4, and opening this bracket, it is minus 8p minus 36 greater than or equal to 0. Simplify that quadratic equation. This is p square 4p minus 8p, that becomes minus 4p. This is 4 minus 36 becomes minus 32 greater than or equal to 0. So p square minus 4p minus 32 greater than or equal to 0. So quadratic inequality, very simple. I am factorizing the quadratic expression. So factors will become p plus 4 into p minus 8, that must be greater than or equal to 0. So by using wavy curve, directly I can say that p lies in the interval minus infinity to minus 4 closed, union 8 to plus infinity by wavy curve method. So that is the third interval. So discriminant will be greater than or equal to 0 when p lies in this interval. Now to satisfy the first condition, second condition and third condition, we have to take intersection of these three. So for the common portion, consider real line. Considering real line, this is minus infinity, say this is plus infinity. That first condition is satisfied when p lies in the interval minus 9 by 2 to plus infinity. Say this is the number minus 9 by 2. Minus 9 by 2 means minus 4.5. This is up to infinity. So in this interval, first condition is satisfied. Second condition is satisfied if p lies in the interval minus infinity to minus 2. Say this is the position of minus 2. That second condition is satisfied in this interval. Third condition satisfied in the interval, p belongs to minus infinity to minus 4 union 8 2 plus infinity. Minus 9 by 2 means minus 4.5. So that minus 4 will be somewhere else like this. So this is minus 4. That is to the right of minus 4.5. So it is valid in the interval minus infinity to minus 4. Again it is valid in the interval 8 2 plus infinity. That is valid in the interval 8 2 plus infinity. So what is the common portion for the first one, second one and third one? So the common interval becomes minus 9 by 2 to minus 4. Therefore I can say that P belongs to the interval minus 9 by 2 to minus 4. This is open, this is closed. So if the given quadratic equation having both the roots to be negative, P must lie in the interval minus 9 by 2 to minus 4. So in the problem he had given this interval is alpha comma beta. No? In the problem he had given that interval is alpha comma beta. So comparing, I can say that alpha becomes minus 9 by 2 and beta becomes minus 4. But we have to calculate the value of beta minus 2 alpha. Therefore I can say that beta minus 2 alpha, beta representing minus 4. So minus 2 alpha becomes plus 9, no? Minus 4 plus 9 becomes 5. Therefore I can say that beta minus 2 alpha is equal to 5. Therefore C option is the correct option. Had given one problem for practicing, you go through it. For more videos, subscribe.